Have you ever looked up at the stars and wondered about the beginning of the universe? The question of how everything began has puzzled humanity for centuries. In this video, we'll explore some of the most widely accepted theories of the beginning of the universe, from the Big Bang Theory to the multiverse theory. The Big Bang Theory is perhaps the most well-known explanation for the beginning of the universe. It states that the universe began as a singularity, a point of infinite density and temperature. Then around 13.8 billion years ago, it began to expand rapidly, cooling as it expanded. This rapid expansion is what we refer to as the Big Bang. According to theoretical physicist Sean Carroll,
the Big Bang is not an explosion in the way we usually think of explosions. It's not an explosion that happened somewhere in space. Rather, it's the expansion of space itself. So, the universe is getting larger, but it's not getting larger into anything.
It was not just an explosion of material into an empty universe that was sitting there waiting to be filled. It was the explosion of space and time into existence to begin with.
Another theory of the beginning of the universe is the inflationary universe theory. This theory proposes that the universe underwent a period of rapid expansion just moments after the Big Bang, causing it to grow exponentially in size. This rapid expansion could have smoothed out the universe and created the even distribution of matter that we see today. According to Alan Guth,
inflation is a very dramatic idea. It basically says that the universe began in a state of extreme uniformity, but then underwent a very brief period of exponential expansion in which it grew by a factor of at least 10 to the 26th power in a tiny fraction of a second.
A twist called inflation that I've worked on attempts to describe the bang of the Big Bang, the thing that caused the universe to propel into this gigantic expansion. But the theory predicts that at very high energies, there should actually exist forms of matter which turn gravity on its head and cause gravity to behave repulsively instead of attractively. And the inflationary theory is basically the hypothesis that this repulsive gravity was the bang of the Big Bang. It's what set the universe into this period of gigantic expansion.
One of the most compelling pieces of evidence for the Big Bang Theory is the cosmic microwave background radiation. This radiation is the leftover heat from the Big Bang and is present throughout the entire universe. It was discovered in 1964 by Arno Penzias and Robert Wilson, who won the Nobel Prize in Physics for their discovery. As George Smoot argues,
the cosmic microwave background radiation is really the afterglow of the Big Bang. It's the light that was emitted when the universe was only 380,000 years old, and it has been traveling through space ever since, providing us with a snapshot of the universe at that early time.
In the early universe, the universe was much hotter and much denser than it is now. It's expanded and cooled, and when it cooled, the radiation moved from the visible, like the sun, down into the near-infrared and the far-infrared, and eventually into the microwaves. And so when we look at the cosmic microwave background, what we're seeing is light that came from the very beginning of the universe, but in its travels over the universe, it's pretty much been undisturbed, except for being stretched out and cooled down by the expansion of the universe.
The multiverse theory is another explanation for the beginning of the universe. It proposes that our universe is just one of an infinite number of parallel universes. Each of these universes could have different physical laws and constants, making the universe we live in just one of many possible outcomes. According to Max Tegmark,
the multiverse idea is really the ultimate in parallel universes. It says that there's an infinite number of other universes out there, and every time there's a quantum event that could go one way or the other, the universe splits into two, so we get a whole bunch of parallel universes that way.
String theory is a theory that proposes that the universe is made up of tiny vibrating strings of energy. It suggests that the universe has more than the 3 dimensions of space we see, and there could be as many as 10 or 11 dimensions. As Brian Greene argues,
string theory is an attempt to reconcile quantum mechanics, which is the physics of the very small, with general relativity, which is the physics of the very large, and bring them together into a single, unified framework that can explain all the phenomena in the universe.
And if I grab one of the neutrons and magnify it, I find yet further particles, little tiny quarks inside. Now that is where the conventional ideas stop. String theory comes along and suggests that inside these particles there is something else. So if I take a little quark and I magnify it, conventional idea says there's nothing inside, but string theory says I'll find a little tiny filament, a little filament of energy, a little string-like filament. And just like the string on a violin, I pluck it and it vibrates, creates a little musical note that I can hear. The little strings in string theory, when they vibrate, they don't produce musical notes, they produce the particles themselves. So a quark is nothing but a string vibrating in one pattern. An electron is nothing but a string vibrating in a different pattern. A neutrino, nothing but a string vibrating in a different pattern still.
While the question of how the universe began may never be fully answered, these theories provide us with possible explanations for the incredible cosmic journey that we find ourselves on. As physicist Stephen Hawking once said,
"We are just an advanced breed of monkeys on a minor planet of a very average star, but we can understand the universe. That makes us something very special."
Some of us might have a problem with what Stephen Hawking said, but that will open up many questions about the creation or evolution of mankind. But that is a topic for another video. Thank you for joining us on this exploration of the beginning of the universe. We hope it has inspired you to continue learning and exploring the incredible mysteries of the cosmos. If you have any questions or comments, feel free to leave them in the comment section below. And please support us by subscribing to the channel so that we can continue to share with you some of the knowledge out there. And most importantly, the controversial ideas and theories that will open up many discussions. This was Sounds of Heaven. See you next time.